afternoon. These are notes for acids and bases worksheet number 2. Polyprotic acids. Acids that can transfer more than one hydrogen ion. There's 3 types. There's monoprotic. You see there's only one H there. Diprotic can transfer 2 H's. There's 2 H's there, H2SO4. Triprotic can transfer 3 H's. You can see 3 H's there, H3PO4. Strong acids and bases donate 100% of their ions or their H ions or OH ions. This means they have 100% dissociation. To dissociate means to break up. Breaking up is hard to do. If you had 100 HCl molecules, 100 H's would break off in solution. There are 6 strong acids: HClO4, HI, HNO3, HCl, HBr, H2SO4. There are some strong bases. All the metals that hook up with an OH in group 1 are a strong base. That's from lithium to cesium, so LiOH all the way down to CSOH. And there are some in group 2, so if you had CaOH2 and then those other ones hooked up with OH2, those are strong metals. Strong bases, excuse me. Weak acids and weak bases. A weak acid or base does not dissociate or ionize 100% or completely. For acids, this means it doesn't easily transfer H to water. The anion of the water wants the H more than the water wants the H plus. For instance, if you had 100 molecules of HF, perhaps only 75 of them will give up an H. This means HF has a dissociation rate of 75%. Weak bases. In a weak base, the cation has a higher attraction to the OH than the water, so the OH tends to stay attached to its cation, thus less than 100% dissociation. Example, copper, Roman numeral 2, hydroxide. Amphoteric. What? It means that a substance can act as an acid or a base by accepting or transferring a proton. Water is the most common amphoteric substance. It can be an acid or a base. This is also called the autoionization of water. Make sure you know this. I will ask it on a test. So here water is acting as an acid. Water here gives up an H. And here water is acting as a base. This water takes an H, and that means it's acting like a base. pH represents power of hydrogens. It's a logarithmic calculation. pH equals 7 is neutral. pH less than 7 is acidic. Greater than 7 is basic. Examples of pH. I'll let you look through these as we scroll. Urine, saliva, both a pH of 6. What does that mean? Seawater, baking soda, Great Salt Lake, milk and magnesia, ammonia solution, milk and magnesia, going back here, right there's Phyllis milk and magnesia. It either helps you have diarrhea or it stops it. I don't remember which one. Ammonia, soapy water, bleach, oven cleaner, liquid, drain cleaner. Holy moly. Brackets mean concentration. OH minus or H plus represent the concentration of either ion in aqueous solution. We must learn about this before we can do the true pH calculations. 2 water molecules get together and one of them says, I want to be the acid. The other one says, I want to be the base. So one water molecule can give up an H, and the other one can take an H. And those arrows represent that this is going back and forth from products to reactants. And from here on, we'll use H plus instead of H3O plus. It's a little easier. Water is neutral because the concentration of the acid and base parts are equal. 3 different possibilities. You are neutral if your base parts equal your acid parts. You're acidic if your acid parts are greater than your base parts. And you're basic if your OH basey parts are greater than your acid parts. It has been proven that the concentration of H is 1 times 10 to the minus 7. And it is the same for the OH. And so if they're equal, that means they cancel each other out and you have a neutral solution. Remember, M means molarity. It's molar concentration, moles per liter. Now, what if we just decided to multiply those 2 together? Chuck, chuck, chuka. You get 1 times 10 to the minus 14th. Do the numbers 7 and 14 ring a bell? Ding, ding, ding. Remember, H plus times OH minus is 1 times 10 to the minus 14th. You'll need to know that. So we're going to do problem 5b for the homework. Find the OH concentration if the H plus concentration is 7 times 10 to the minus 7th molar. Is the solution acidic or basic? Let's get to business. So we should remember that H plus times OH minus is, that's a 1.00 times 10 to the minus 14th molar. And the question is asking us to find the OH. We can isolate OH algebraically. OH is 1 times 10 to the minus 14th divided by the concentration of H plus. And then we just plug in our numbers. 1.00 times 10 to the minus 14th, I believe that's molar, divided by the H is 7.00 times 10 to the minus 7th molar, and you get out your calculator, you do a little dance, and what do you get? You get your H is 1.43 times 10 to the minus 8th molar, and now you have to answer, is this acidic or basic? So you need to compare the H's and the OH's. The H is actually a bigger number than the OH, hence the solution is acidic. Your homework is worksheet number 2, 1 through 7.